Good morning and welcome to the today's lecture in the short course on the satellite meteorology application in weather and climate. Today's lecture is on satellite-based monitoring of aerosol particulate matter and impact on regional environment. This lecture is also delivered under the banner of Azadi Ka Amrit Mahotsav. So, as you are all aware that in the composition of the atmosphere, we have it consists of the permanent gases, trace gases, and variable gases. So under the variable components, we have aerosols and water vapor. The aerosols are highly spatial and temporal variable, and the interaction of aerosol with the environment are very complex and has not been well established. Now, what are the aerosols? Aerosols are it is a system of small colloidal solid or liquid particles or droplets which are suspended in the air, and these are the visible part of the air pollution. Gases, as we have, this very small tiny particles which are not visible in the air pollution, but the aerosols are the visible part in the air pollution. Of course, the smaller part of the aerosol are also not visible, but the larger sizes are visible. Now, what is air pollution? That is the airborne particles and gases which occur in the concentration, which is endangered to health and the well-being of organisms, and which also affects the environment, is known as the air pollution. Now, these atmospheric aerosols, which are tiny solid or liquid droplets suspended in the air, originates from natural and anthropogenic sources, and the lifetime is very small, for a few days to weeks in the troposphere, and when it goes in the stratosphere, it takes a few months, few years, and the sizes ranges from 0.001 micron to 100 microns, and you can very well see that different names have been assigned to it. These finer particles are also known as fumes. The larger particles are dust, and that is divided into ultra-fine particles, fine particles, and coarse particles. And smog, fog and mist, smoke, and cloud droplets. So these are the names of the particles, and depending on the sizes of it, and this fall in the same class of the aerosols. And I said that their resources are natural as well as anthropogenic. Natural, so under the natural sources, mostly it originates from the mineral dust, then sea spray aerosols or sea salt aerosol from the oceans, then the volcanic ash, of course the fire, forest fire. Under the anthropogenic, the vehicular emissions, industrial emissions, and the lot of anthropogenic activities. In fact, the percentage, in terms of percentages, we see the natural aerosols consist of around 85 to 87%, and 11 to 13% constitutes their anthropogenic aerosols. But over the years, this percentage has been increasing, and the effect of the anthropogenic aerosols is much larger than the natural aerosols in terms of interaction with the electromagnetic radiations, or the interaction or the impact on the environment. Now, the aerosol, what happens is this absorbs and scatters solar radiation, but when it is in the atmosphere, so it interacts with the electromagnetic radiation in form of scattering or absorption, depending on the property of the particle, and then it modifies the solar budget or the radiative forcing. So non-absorbing or the scattering aerosols are, as I said, the sea salt aerosol, the dust, the sulfate, nitrate, and the Absorbing aerosols are mostly the carbonous aerosols, which produces the warming effect, and the scattering aerosol produces the cooling effect. Also, the absorbing aerosols not only produces the warming in the atmosphere, different vertical profiles in the atmosphere, but also when it is deposited on the snow or glacier surfaces, so it provides, it changes in the snow albedo, that is, it absorbs the solar radiation, so it produces less of albedo, and then it triggers the melting of the snow and glaciers. So that is also a negative effect on our environment. So depending on various applications of aerosol, they are also the nomenclatures are also slightly different. We in the environmental application, the aerosols are also known as classified as total suspended particles. You have heard of particulate matter. This particulate matter, what is particulate matter? Particulate matter aerosol is referred to the generic term. This is particulate matter. Uh, that is a complex mixture of the aerosol particles. So it is also known as a particle pollution, which is a complex mixture of the airborne, the solid or liquid particles which are suspended in the air, and it is a mixture of everything. It can be mixture of nitrates and sulfates. It can be a mixture of ammonium. It can be mixture of the black carbon, water vapor, organic chemicals, or etc. etc. So it is a complex mixture of that. And as the rule book says that the aerosols classified as the sizes of different particles. So particulate matter aerosol are also the same thing. Particulate matter aerosols are classified according to the sizes. So we say the famous nomenclature is PM1. That is the particles which are less than 1 micron. Then PM 2.5, that is the particulates sizes or particulate matter sizes aerosol whose sizes are less than 2.5 microns, and PM10, this is larger particle whose sizes are less than 10 microns. So these are classified as PM1, PM2.5, PM10, and depending on this, the concentrations are classified. Hence, in the air pollution or in the air quality, also we come across these terminologies of aerosol particulate matter, wherein the concentration of PM2.5 is assessed, and it is also disseminated PM10, and these have a different effects on the human health, the well-beings of the organisms on the earth surface, or in the environment, in the atmosphere. So as I said, the sources are these are the sources. As I said, the maximum sources are from the natural surfaces, and as I said, the mineral dust, the forest fire, the sea salt, because the ocean cover most of more than 70%. So hence the natural aerosols are from the sea salt or the oceans, and of course the volcanoes. And anthropogenic sources are, as they describe, the vehicular, industrial, and various anthropogenic activities. Now, now the aerosols are also the essential drivers for the climate change. They influence the Earth energy budget. As I said, these are emitted in the atmosphere, and they have various perturbations to the electromagnetic radiations. They have the cloud interactions, because they act as a cloud condensation nuclei, and the formation of different clouds, different levels, and these clouds also affect the solar budget, because various scattering and absorption phenomena changes, and also it leads to changes in the hydrological cycle, that is the precipitation patterns. So they influence the Earth energy budget in various ways. Indian region, particularly when we talk about the Indian region, they are influenced by various aerosol species, which I said in terms of the hydrological cycle, the increased evapotranspiration or the evaporation, then the vertical atmospheric structure, atmospheric temperature structure, and it also affects the chemical reactions in the atmosphere, the secondary aerosols, which are chemically formed in the atmosphere. With the rapid growth in the population, industrialization, and the urbanization, which is happening mostly in the South and Southeast Asia, this aerosol contribution is increasing significantly, and they are producing different forms of aerosol. And aerosol, as I said, it's a complex mixture. So we say a terminology isn't that particulate matter. Aerosol particulate matter is increasing over this region, over Southeast Asia, East Asia, and this leads to more of anthropogenic aerosol loading over this region. And over last 2 or 3 decades, this has increased substantially. And when it reacts with the or interacts with the electromagnetic radiation, so it affects the solar insolation or the solar budget. So contributing to solar dimming, that is the less amount of solar reaching on the ground, that is direct effect, and also some indirect effects in terms of the cloud condensation nuclei, changes in the cloud properties, changes in the hydrological cycle, and so on. So the long-term decline in we have observed the ground data suggests, and it observes that there is a decline in the monsoon precipitation patterns, changes also in the precipitation patterns, which are partly associated and also being studied, proved that these are due to the anthropogenic aerosol forcing and over this region. So the IPCC studies also suggest that the impact or the contribution of the aerosols is also substantial. So over these are every 5 to 7 years, IPCC come out with a detailed scientific reports on various contributor to the climate change. Apart from the greenhouse gases, as everyone know, the greenhouse gases, the total radiative forcing over the last 1 decade has increased by around 0.4 watts per meter square. If you see IPCC 2013 and 2021, it has increased to 0.4 watts per meter square. Now it stands to 2.7 watts per meter square. So greenhouse contribution is very well known because it is stable, because it has been proved and very well. But due to the variability of the spatial variability of the aerosol, spatial and vertical variability of aerosol, it is very difficult to assess the contribution. But over the years, the vast number of studies over entire globe, and if we talk about the Indian subcontinent also, many studies have been done through ground and as well as the other means, satellite and other means. And now it is at a very high confidence level that the contribution also is by, and they have quantified the contribution from the aerosol particulate matter. So the increased the studies of the aerosol cloud interaction has given a way to suggest some number, that is radiative forcing number for the aerosol contribution. Now the aerosol at lower heights, that is near to the troposphere layer, they scatter more of the shortwave radiation and produce a cooling effect. Whereas the aerosol which rises to the higher atmosphere, it stays for a long time there because the lifetime also increases. And if the lifetime increases, it means it has more scope of interaction with the solar radiation. Now, more interaction with solar radiation means more perturbation, and more perturbation means more of changes in the atmosphere. So, and also due to the wind and other dispersion phenomena, they move from one height to other height, from one place to other places, and their residence time also increases, and it produces long-term radiative effects. So, when these aerosol rises to the high altitudes, it can also produce warming effects, and it acts as if like a greenhouse gas. So if you see in this figure, this is the black carbon. If you see what black carbon aerosol produces the positive radiative forcing, that is, it produces a warming effect. So the aerosol particulate matter below the boundary layer height are affecting varieties of ways, like in the visibility. We see that there is a change in the visibility. If there is a more pollution, more of aerosol particulate matter, the visibility decreases. It also affects the air chemistry, that is the secondary aerosols. Then also it affects the human in terms of human health. It deteriorates our human health, and lot many problems are created due to the pollution, air pollution. Then also it dissolves into ocean. So the aerosols, because it has lot many species, nitrates, sulfates, carbonous aerosol. So these are having acidic in nature. So when it dissolves in the ocean, so it changes the ocean fertilization, that is pH value. So more acidic water is becoming, so pH value, and when pH value changes, there is a change in the aquatic species. So that also it affects. It also affects the, as I said, the hydrological cycle, hydrological pattern, also the snow and glacier melting, which is, and many other phenomena. So as I said, the particulate matter is a complex mixture of various particles in the atmosphere. As I said, these are PM10, PM2.5. Mostly we say about PM2.5 and PM10. And these are also, like PM10 are also known as inhalable particles. The terminology, as I said, with different applications, different terminology will be different. So whenever you have come across inhalable particles, so it means it is PM10. We are talking about PM10. And these are coarser particles, because PM10 is a coarser particle as compared to the other aerosol domains. And these affect the human health because it infiltrates. When we inhale, it goes over human respiratory system. And if you recall, I said it's a complex mixture. It can be nitrate, sulfate, acidic, acids, and many things. So when we inhale it, and when it goes inside our respiratory system and our human body, so it is a chemical, and it produces lot many effects, ill effects, and that's why the air pollution is dangerous for human health. When you talk about PM2.5, these are also known as the respirable particles or fine particles. Whenever you come across fine particle or the respirable, we say that it is PM2.5. That is all particulate matter whose sizes are less than 2.5 microns. So these are fine particles. So when we inhale, so it from the respiratory tracts, it goes to our blood vessels. It can travel to our blood vessels, and entire body it can have a negative effect. So these sizes are classified according to their potential of causing harm, or potential of causing the health problems in our human system. Now, if you talk about the overall, the right hand side, if you see, these are the health effects. So the respiratory problems, asthma, bronchitis, or the chronic pulmonary disease, any chronic pulmonary disease, long-term exposure. When we have a long-term exposure to the hazardous, that is the particulate concentration. So the human health is deteriorated in terms of any of the diseases, the chronic pulmonary disease, pneumonia, any respiratory problems, in terms of cancer, and in fact diabetes. The type 2 diabetes are also been related to the air pollution, particularly the aerosol particulate matter, of course, and allergies, various type of allergies, whether it is allergy to the eyes, nose, or throat, the inflammation of the lungs and tissues, the lung functions. Also, children below 5 years, 7 years of age, they're also affected by severity of this particulate matter concentration. So, and the premature deaths are also the underweight, the malnutritions also related to that. The premature death, because most when they have long-term exposure, so there is a possibility and proven fact that the lifetime of a human being is decreased by around 4 to 5 years in terms of this area. And world over, if you see, it is 3 to 4 years. But if you see the South and Southeast Asia, it is around 4 to 5 years. And if you see this graph, is a toxicity level. So x-axis is your particulate diameter, that is PM1, PM10, 2.5, PM10. And if you see the y-axis, it is deposition efficiency. It means whenever a particle sizes of PM 2.5 or PM10 enters our human respiratory tract, how well it is deposited and what is the possibility of coming out. If you see, this is the total. This means the respiratory tract. This is TB and NOPL are the respiratory sections of our respiratory tract from the nose to our lungs. And if you see this total graph, this is from your nose to your lungs. That is lung diaphragm. As the particle size decreases, that is PM 2.5. PM 2.5 is almost 80 to 100%. It means if a particle enters, one particle of PM 2.5 enters our human respiratory tract, it will never come out. It has a highest possibility that it will interact and it will produce ill effects in our human body as compared to PM10. PM10 is around 50 to 60%. Now, if we talk about the environmental impact, as I said, it changes the cloud condensation nuclei. The cloud properties changes, impact on the monsoon circulation, impact on the crop yield. It can cause droughts and floods because of the hydrological cycle, monsoon, the circulation patterns. Of course, the absorbing aerosol can produce melting of ice and glaciers. The visibility, the damage to the environment, aesthetic effects, because as you see, the many sculptures or many monuments, and the chemical properties of the aerosol also reacts with the different agents, and then it deteriorates or damages our beautiful monuments and structures. So the main type of air pollution, as I said, these are the sources: the vehicular pollution, the power plants, refineries, industries, the biomass burning, firewood, and of course the residue burning, which is common in this area of South and East Asia and Southeast Asia. So as I said, the one of the problem of this pollution, which is also, that is the aerosol particulate matter pollution, is the problem for the human health. That is, if you see the true diagram, the true picture of the left hand side is the healthy lungs, and this is a lung or person who is long term exposed to the air polluted area, and the carbonous, the black carbon or the emitted anthropogenic aerosols are deposited in the over the lungs. And I said this is the PM 2.5, and it will never come out, and it will produce many diseases, as you have discussed in the earlier slides. It is estimated, and it is different air pollution reports, that around 7 million people die all over the world only due to the air pollution. And in this, more than 60% out of 7 million people, more than 60%, that is around 4 to 4.5 million deaths, are only reported in India and China. That's why most of the Indian cities are most polluted, because a lot many pollution sources, agents are there, as we discussed earlier. What are the sources? And these are affecting our younger children and older people. Of course, these are outdoor pollution, and indoor pollution is also there because of the various household cooking habits, and they are also contributing to the aerosols and also to the deaths. And also the important point is, because this is not only deaths, but also it is also lost monetary loss to our GDP. So if we talk about India and China, it is around 2 to 3% of our GDP we are losing every year because of the money that goes in the in for saving the life of people for the air pollution and the treatments of the different things for the air pollution. If you see satellite picture of this region, this is of 2005, 2009, and 2015. If you see that these are the hotspots, the eastern part of China and the Indo-Gangetic Plain, as I said, because of the population, the urbanization, the industrialization, these are the sources, and these are highly industrialized regions of China, the eastern part of China, and North India is a highly fertile land, lot many pollution, lot many industries, and also the important is weather patterns, because the weather patterns also plays an important role in dispersion of the pollution, because the, the sources can be one place and the impact can be at other places because of the dispersion. So because of the natural meteorology of this region, the most of the uh, uh, pollution is contracted here in this region, in the Indo-Gangetic Plain and the eastern part of China. And satellite data provides an important monitoring tool to assess the amount of and the changes which is happening on the ground by different sources, and if the government policies are implemented, what is the impact of the policies, whether we have seen a positive impact or a negative impact of the policies. Now, if we see the different these are different slides. This shows that because the air quality or air pollution monitoring is important to better understand the sources levels of different air pollution, and to make an awareness of people that what the air pollution or the air quality makes a day-to-day life, and how to prevent it, or how to be in a comfortable zone if there is a problem, how to minimize it and be in a comfortable zone. So the policy maker, so it helps the policy maker to control the exposure of human beings or well-beings to the air pollution. So this is air quality index. So different countries adopt this scheme. India has also adopted in 2014 the air quality index. So in this, the government or the agencies, they disseminate the information of the different air pollutant constituents to the general public. The purpose of the air pollution or the air pollution monitoring is not to collect the data, but also to provide this information to general public, to researchers, and to policymakers, so that they can work in tandem and even manage and improve the quality of life of people. And these air quality indexes or the air pollution indicators, I can say the air pollution indicators, they provide information to general citizens, and to take a meticulous decisions at the citizen level also. So not only the at a policymaker or the government level, but local citizens, one-to-one citizen can also take a decision depending on the air pollution indicators. So if you can see that these are WHO and India has adopted this one. So these are the 8 indicator or the eight constituents of the pollutants, and in that PM10 and PM.5, 2.5 is a must. So when we calculate the air quality index, in that any three pollutant can be measured by any three pollutant out of 8. And in that any three, PM is a must. Either PM10 or PM2.5 is a must. So that is the most weightage of the pollution is on the aerosol particle matter. So different ranges, if you see, suppose it is, if the PM2.5 and 24-hour average, if it is 0 to 50 microgram per meter cube, so it falls under a good category. And if it is within 100, it is satisfactory. And when it crosses 100 micro per meter square, it becomes the concerned, moderate, poor, very poor, and severe. So when it becomes the poor, 250 microgram or PM, when it is PM 2.5 above 90, so it is unsafe to be exposed outside, that is outdoor air pollution, and needs an immediate action by governments and by citizens. And the status has to be monitored every hour and every day. And when it crosses the very poor category, so government take actions by the local authorities. Local actions. Sometimes you heard that the schools or the public authority, they say that it should be shut down, and people are also advised not to go in the outside for morning walks and other reasons. So these are the advisories depending on the air pollution indicators, the policy and the individual people can take it. And these are the guidelines. Left hand side, WHO, US guidelines, and India guidelines. And WHO in 2021 also revised their guidelines. So the 24 hours, this is the annual average, and this is the 24 hours average. So PM 2.5 24 hours is 25, and if you see India, it is around it is 30, and PM10 is 50. So if I said that Indo-Gangetic Plain is a very hotspot region, because here a lot of activities happens. The anthropogenic dust storms, because the dust which travels or dispersed from the northern Africa region, Sahara region, so they travels from long distances upper tropospheric heights, and it travels to long distances, thousands of kilometers, and it affects this region also. And during the pre-monsoon time, the dust storms produce a lot of perturbations or a lot of pollution over this region. The sources are different, and the problems or the due to the dispersion, it can have an effect on other areas as well. The crop residue burning, different parts of the pre-monsoon, pre-monsoon and the post-monsoon season, a lot of industrial and the lot many population, and due to that lot many fog and haze and smog phenomena occurs here. And due to the low wind speed, due to certain time frame, the particles are not dispersed very fast and are very slow and trapped in a column of the atmosphere, and then it produces a long term in the weeks to months. Of course, forest fire is also a part of that, and then this is the influx and this is the outflux. And if you see the air quality map, this region is always highest. This is the eastern China, the Southeast Asia, including the Myanmar and the South Asia. This is the hotspot for the air pollution, because some are natural and some are anthropogenic. So some are under our control and some are not our control. Now in this, the satellite data. Now, as I said, the one phenomena is one you can measure on the ground, but using different instruments. But satellite data provides a very vital and useful tool to measure the particularly air pollution and particularly aerosol particulate matter pollution. A single satellite can carry one or more instruments that you very well know on board of the satellite. And the satellite, the Earth observing satellite goes to around 400 to 700 kilometers above the Earth's surface, and it obtains a very well tool to observe continuously from a certain height, that is eye in the sky, in terms of measuring the aerosol concentration. So the electromagnetic radiation that is coming from the sun, it interacts with the Earth atmosphere and the surface, and the radiation is either reflected or absorbed, by the surface or the atmosphere. When we talk about the atmosphere, the composite signal which is reaching at the sensor level or the satellite level are the radiation or the reflected radiation by scattering or the absorption from the surface as well as from the atmosphere. So if we subtract the contribution from the surface, so we are only left with the contribution from the atmosphere. So from this atmosphere, from the physics law, from the Lambert-Beard law, we convert it to the concentration of the atmospheric constituents, and we estimate the particulate matter concentration, particulate matter aerosol concentration. And these spectral measurements, when we combine with the radiative forcing calculations also, because we know the type of the aerosol, the vertical column, the different radiation properties. So we try to assimilate the radiative transfer calculations, and then we try to infer the amount of or the properties of the atmospheric constituents. In that, the aerosol optical depth, which is an extension property or extension coefficient, it is an column, because satellite measures a columnar integrated property, because it measures from the satellite level to the ground, and it measures the integrated columnar aerosol value. And we very well know that the most of the concentration is residing over the below the tropospheric level. So that is the concentration of our atmosphere, because most of the atmosphere are in the troposphere, and the our aerosol particles are also in this lower tropospheric region. So aerosol optical depth is an indicator or the columnar integrated value that is from the satellite to the surface. And the aerosol loading or the aerosol optical depth is also relates to the particulate matter concentration, because aerosol optical depth is a unitless quantity, that is an extension coefficient, but particulate matter is a concentration, that is mass value. So the extension coefficient also directly relates to the particulate matter concentration, that is in terms of the volume density or the mass density. So satellite data doesn't estimate directly particulate matter particulate matter concentration, that is either PM2.5 or PM10. It is indirectly calculated by the aerosol optical depth. So aerosol optical depth is a indicator of the extension property, which is calculated by the radiative transfer equations, that is how much the solar radiation is scattered or absorbed at the satellite level, how much radiation is reaching at the satellite level. We calculate the aerosol optical depth, and from the aerosol optical depth we indirectly calculate the PM2.5, that which is in terms of the mass or volume density. So from this aerosol optical depth also we calculate different properties of the aerosol, that is the physical property, what is the refractive index, or what is the size of the particle, what is the single scattering albedo, what is the whether the particle has more of absorption property or more of the scattering property. So then we segregate from this measurement the different properties of aerosol. So in terms of the particle size, in terms of the composition, in terms of the vertical distribution, in terms of the hygroscopic growth, etc. So in the nutshell, I have put in the slide how satellite observations are used to address the air quality or the air pollution issues. So as I said, the satellite measurements are the gap filler, because how many monitoring stations one can put, because it has a footprint, and it requires a lot of money, a lot of manpower, some malfunctioning, some it can stop also, ground station can stop. So we have a gaps. So satellite data is as a continuous data, daily or in an hourly basis also. From the geostationary we can have a very high representativity, which means every 30 minutes also we can have data. So we have a high temporal resolution gap filler. We can measure continuously the pollutant loading, that is aerosol optical depth. And from this we can have lot many estimations. Also we can have a transport modeling from one region to other region. where for example, there is a dust storm over this region. So there is a pollution over this, high pollution over this region this week. So we can also find out from which area, what are the sources of this dust storm. So we can also, from the air mass back trajectories, also we can find out what are the sources of this pollution. So long range dust transport also can be find out. Also the vertical profiling, because which cannot be done from this ground station. So vertical profiling also at different heights or different levels. What are the types of the aerosol? What aerosols are residing at different levels of the aerosol, and from where it has come? So what are the sources for different levels of the atmosphere in the atmosphere? So this satellite data can also help in regularly monitoring and checking of the air quality over industries or mines, which is laid by different that is the protocols laid by different agencies or government. So need to have measurements regularly. So satellite data can provide a vital tool for that. As I said, the air quality index, which different countries and had adopted. So in that, satellite data also can aid or help. Of course, when there is a fire, when there is a forest fire, or there is any stubble fires, so continuous monitoring, day-to-day monitoring, hourly monitoring of the fire or the fire occurrences, fire count, or the fire direction can also be accurately assessed from the satellite data. Of course, in the forecasting domain, because of lot of parameterization, forecasting satellite data also plays an important input in the forecasting models. So in terms of forecasting the air quality, which not many agencies in India, they give the forecasting 24 hours to 72 hours forecasting also can be done using satellite data as one of the inputs. Now this also aids, as I said, the monitoring stations. India has, is one of the lowest in terms of the density of the monitors, the monitoring stations. So in that, in this region, satellite data plays an important role. Now, in terms of when we talk about the satellite data, the geostationary satellite and polar orbit, the geostationary, as I said, the high temporal resolution. Every 30 minutes we can get data. So INSAT is in over India, GMS from Japan, Meteosat from Europe, and GOES from US, and these provide different parameters. And in that, the aerosol optical depth is one of the parameters. And of course, the Earth observation satellite, the polar orbit satellite, we have a different series of satellites. Aster is one of them. Modis is one of them, which is having 36 bands. Then we have MISR. This is the important is not only the Nadir view, but also it has a different view angles. Different view angles it measures the aerosol optical depth. IIRS, visible infrared imaging radiometer suite. So it has many channels, and in this in the visible channel we can also have the aerosol measurements, aerosol optical depth. SMOPIT, measurement of pollution in the troposphere. So it is, as the name suggests, it is measuring the pollution. So not only the CO, but also it measures the aerosol. Sentinel 5P tropomy also provides the high resolution, that is around 5 to 7 kilometers high resolution. It provides it provides the aerosol measurements apart from many other parameters. Sentinel-3, the OMI, ozone monitoring instrument, it also provides the aerosol measurements. So I'm focusing on aerosol, but there are different parameters. It measures ozone, it measures the NO2, it measures the SO2. But apart from that, it also measures the aerosol optical depth. This is a geostationary satellite, GEMS. This is from the Korea Republic, that is South Korea. So it measures so many parameters apart from the dust and the aerosol measurements. GOSAT from Japan, it also measures, one of the parameters is aerosol optical depth. When we talk about the vertical profiling, so LiDAR-based instruments provides a solution for that, and Calypso is one of the instruments. That is the cloud aerosol lidar and infrared pathfinder satellite observation. So as we see the different profiling, this is different height. These are the latitude, longitude. There is the positions. That is the spatial position, and y-axis is the height. So different domains, we have different heights. We can see where are the different types of the particles. So in the nutshell, if you see these are the geostationary satellite. So they have high temporal resolution. Day and night we can provide, and spatial resolution are low, around 2 to 4 kilometers. Whereas the orthogonal satellites, as the highest, it can be around 300 meters to 1 kilometer. 300 meters to 1 kilometer aerosol optical depth. So in this way, we can see the temporal, annual, or the seasonal, or daily profiles. Also, we can see using the satellite data if any part of the region, whether it can be over a urban area, or a city, or a region, or across the whole world globe. So this is the INSAT data. So it covers around 3,000 kilometers, and you can see that from the Middle East to the Southeast Asia, and it gives a coverage every 30 minutes. And we can have it is superimposed aerosol optical depth as well as the fire points. So how progressively every half an hour or every day we can see the progression or the impact of the polluting sources. This is the dust events. And if you see every half an hour, we can see in the visualization also we can see that how the dust storms are progressing. So this is just an animation which shows that how well we can estimate every half an hour the air quality or the air pollution in terms of the aerosol. Now, if we see that due to the stubble burning during the post-monsoon and the pre-monsoon time over this region, northwest Himalayas, northeast region. So this is the smoke. The white color you can see smoke, and these are the red dots are your fire pixels. So every day and across the whole decade also you can see how the fires have been increased or decreased, and what is the impact over the of these sources on the air pollution, whether the pollution has decreased. And this also travels to the Indo-Gangetic plain and Delhi. If you see that we are always hearing that Delhi and NCR region, there is always a pollution, always a suffocation during this time, because the sources are different. Sources not Delhi, but it travels to long distances. If you see that during the pollution, the stubble burning time, so whole of Indo-Gangetic plain is full of the aerosol loading, whereas the that is before and after the stubble burning phenomena, this disperse, and the air pollution is not much at the severe level. And we can also see from the back trajectory, air mass back trajectory, that from which region this has been coming, and what are the sources, and what is the concentration which carries from one place to other place. So it starts from here, and the concentration increases, and it goes to the central part of the Indo-Gangetic plain as well. And this is the pollution level. This you see the highest level during the post-monsoon season, and this is PM 2.5. How it increases during this time, and there is a severity of these pollution episodes. And this is the Calypso, that is the higher, that is the vertical profiles. During this episode, we can also see what aerosols carries and what stays at what level, and what is the impact of that. So over this over 2 decades, we have also, our study shows that over 2 decades, this aerosol loading has increased almost by 10%, and the particulate matter PM 2.5 pollution has increased almost by 17.5 level, and this is 4 to 5 times high than the permissible Indian standards of PM 2.5, and that's why there is a lot many hue and cry about these episodes during this whole region. And different aerosol properties. As I said, from the aerosol optical properties, one can also study different properties. There is angstrom exponent, absorbing aerosol optical depth. So what is the nature of the particle? What is the size of the particle? where what is the origin of the particle, whether it is a anthropogenic source or it is from a natural source. So all the studies can be done via using the satellite derived aerosol particulate matter. And aerosol optical depth, as I said, it can aerosol particle matter, it cannot be directly calculated, so it has to be calculated from the aerosol optical depth. So there are various ways for that. It is just a regression model or a multivariate model. So using a multivariate model, it includes not many parameters of meteorological parameters as well as boundary layer, as well as aerosol optical depth, and many things, and different profiles. And then from the aerosol optical depth, the particulate matter concentration map can also be generated, and this helps because as in the air quality index, PM 2.5 and PM 10 is important position. So in this, satellite data can also play an important role for monitoring, forecasting, and dissemination of information to the general public in terms of the air quality index or air quality species. Thank you. I think I have given most of the information in this time frame. So now this forum is open for any clarifications and questions. Thank you.